go to 2-1 then. Set theory. Now this is a whole different ballgame. Let's just talk about populations in the United States. As you can see, they're shifting. In 1960, the populations were such. Hispanic, and so on. Notice that the population in 1960 for white people was about 80%. It dropped down to 60, and it's going down less and less. Hispanic population is going up and up and up. Asian population going up, and the black population is fairly constant. This is just interpreting and reading a graph. Now, is it accurate? I don't know. Probably pretty accurate. But things can change, as they well do. Let's go right here. A set is a collection of objects. It should be defined so it's specific. An element is a member of the set. So you have members 2, 5, and 7, 5, 2, and 7. The order doesn't really matter here. Example 1. The months that begin with M. In the English language, they are March and May. Solution is separated by a comma. The roster method. Write the set of natural numbers. The natural numbers do not include negative numbers. So it's 1, 2, 3, 4, 5 because it's less than 6. Now, write the set of odd natural numbers greater than 4. It's 5, 7, 9, 11, and dot, 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 keeps going on and on. This has what we call set notation. And it's looks like this. We'll mark there. This is pretty easy. This is the listing. They call it the roster method. Now, understanding set notation. This is 27, and it says decide whether each statement is true or false. States west of the Mississippi. Oregon is west of the Mississippi, so yeah, it's a member of A. 27 is an element of this, so we have to figure it out. 1, 5, it's every 4 numbers. After 25 comes 4, it's 29. 27 is not in this, the B is no. This one says Z is not an element of this, and of course it's there, so this is also false. So 3 is kind of tricky, but I hope that makes sense. You guys good with number 3? Anybody can give me an amen on that? Maria, you good with that? Are you still there?
Yes.
All right, number 4. Describe the set using the descriptive method. The descriptive method, describe B contains 2, 4, 6, 8, 10, and then 12. Well, you have to look at it and say, well, what does that look like? It looks like even numbers. Less than 13? Less than 14? There you go. All the elements in the set of even natural numbers that are less than 14. You could say less than 13. You still have the same thing. So you're just describing it. And in math, you'll do that sometimes. Now, set builder notation. Now, there are really methods for getting answers, usually. First method. First method usually given is graphical. So if I have a graph, this is 0, this is 1, and I want all these elements in here between -1 and 1, this is the solution. It's called graphical notation. Interval notation is number 2. They called it roster method, but interval notation would be this. Meaning that it includes an one. If it did not include it would be a parenthesis. And the last one is set builder notation, which means all x such that x is, and in this case, you would write less than 1, less than or equal to 1. X is, let's see, the best way to write that. Not bad. This says all x such that x is greater than or equal to -1 or less than or equal to 1. So this is your 3 methods that are primarily talks about them differently, giving kind of a different name, but let me assure you that the mathematics are still the same. So here we have x such that x is an element of E and x is less than 7. So that's how they show it here. Now on the test, I will prepare you for what your answer should be. But if they have a set builder notation, I ask for set builder notation for your response, this would be one possible answer. They might show other ones, but they have to read out and match what you have here. The solution has to match the numbers in what you're trying to describe. Okay, so here's another example. Designate the set S with elements 32, 33, 34, 35 using the roster method, descriptive method, and set builder. So there you go. Now, this is what I just got through showing you, but with some different numbers. And I use graphical notation. This is more like interval notation, and that would be a bracket, and a bracket on this side. But this book uses this designation, this marking here. The descriptive method, that S is a set of natural numbers greater than 31. I mean, you just look at it and say, well, okay, those are all whole numbers. Therefore, they're natural numbers greater than 31. And then here they have some element of n, and means natural numbers, and that the number, whichever it is, x, has to be greater than 31. So you might study 6 for a little bit to see how they do it, but I wouldn't spend too much time on it. This is write a set using an ellipsis. Well, if you look up here, the roster method, there it is there again. And instead of calling it the roster method, They said ellipsis. Now, the null set. The null set is shown with two brackets with nothing in it, or a zero with a line through it. It says, which of the following sets are empty sets? The set of woolly mammoths, fossils, and museums. Well, that's not empty somewhere. That's not empty to show there. A living mammoth, well, I don't know. I think there's none of those. So I would say that's an empty set. This one here, this is not an empty set. It has this in it. So it's a goofy set, and it has the element that's in it. Remember, the empty set has nothing in it like this one above. So this is tricky, and I won't trick you on my test. If something like this comes up, if they throw in something like this, and I don't have a chance to stop it or make it make sense, I'll let you know what to look out for. So don't worry about that. But no. No. Yeah, of course. Yes.
So in B and D, I don't understand when there's the X, there's that line, and then there's another X. What does that line symbolize?
This says X, such that X is a living woolly mammoth. This is the set of all X such that X is a living woolly mammoth. It's red, X. This line means such that X. Of course, there's no such thing.
Okay.
That's empty. C says, let me explain C a little bit better, probably. That's kind of a good question. I appreciate that. So C says this. C says you have something like this. This is the empty set. Not very pretty. The empty set has nothing in it. Empty. But if I put something in it, no matter what, it is no longer an empty set. This one has an apple in it, or a cherry. So it's not an empty set. It's not a number, but it's not an empty set. This, in fact, is an empty set. Or you could write it like this, as an empty set. But if I put this in this, it becomes this, and therefore it is no longer empty. It's confusing a little bit, but empty is empty. It's empty. And yeah, it's confusing. But when the test comes, I'm not going to let it be confusing. All right. Number 9, the cardinality of a set. Now we need to read this. The cardinality number is a set of the number of elements in the set. For a set A, the symbol for the cardinality is read as N of A. Find the cardinality of each set. Well, look, how many are there? 1, 2, 3, 4, 5, 6. 6, since it has 6 elements. That's the cardinal number. That's the most that it can be in there. Okay, X is less than 16. It's a natural number, so it's got to be 15. And there it is. B is 15. Now, here is a question that students sometimes ask. What if the number is repeated? Well, has no cardinality. It cannot technically repeat the number. So, for example, in element A, or find the cardinality of A. If I put 5 in here twice, the cardinality is still just 6. D, the tricky one. So let's look at C. C has a 1 element in it, so it has the cardinality is C. They don't even write cardinality anymore. They write C has 1 element. Now D is known as the empty set. Notice it's not in those brackets, it's by itself. So there are no elements in it. It has a cardinality of 0.